All right, I go. So let's try this one. Loops. So we have this one here, I1, I2, I3. Second step, any super loops? Yes, I have a super loop. Because there's a current source here. Yeah, so since I have a current source there, I need to do this. I need to join the two of them up together. So we have, so we could go, say we start here, right? Join the two loops together, right? So we can start here, go up here. Here, we just treating this like a not here for now, right? Because our current source. Yeah, so that's not there. For now, it's not there. Let's act like it's not there, right? I repeating, it's not there. So nobody asks me why we didn't go through the current source. I think I explained that like 1,000 times before. To have no voltage drop. You don't know the voltage drop. So we're going from 1 to 2 to 3 to 4. Well, we had to go through here. And we got to go through here. We had to go through here. And back to 1. But I loop there. Yeah, we had to go through this because that is the units. We could get back to the other loop, right? That is the starting about. So let's go and get this bread. All right, so we have food back right equation. All right, so on the bottom, there's a map of equation. So we're going from 1 up, rise. So we call that I super loop because I'm not going through that. So that'll be 12. We have 2 up to 3 across to 4, so that'll be minus 200. And the I1 loop, so we minus 200 I1 across the 4 down to 5. Now we're going through R1 that have 2 current going through it. We have I1 and then we have I3. Yeah. So I do like you do it like we are accustomed doing it. So it could be minus 2,000 I1 and plus 2,000 I3. So we're back at 6 down to R16. So same thing. It could be, well, in this case, we have 2 separate currents, right? So you have to treat that little difference. So you just say, it don't matter what you do. So you minus 1,000 I2, and I could just say plus 1,000 I3. It don't matter if you write plus, it just matters how you write it, right? So now that whole thing there, you're back to 7, you're back to 1 is equal to 0. I could write plus and minus it. It really matter because we're not winning I1 loop and the I2. Yeah, there's the super loop. So since we in the I2 loop, which is part of the super loop that we assume, anything that I2 going through will be negative and anything going against it will be positive. Just like what we said before. Remember, as a super loop, we treating this whole loop here as one loop. Yeah, and you notice the whole thing in clockwise direction. If I was to that right clockwise, you'll notice that this here still going against it, so it will still be negative. All right. So now we are already the length equation for the node, the current source. So now we have to act like it there now. So I have to erase this here. All right. So what current going with it? So we have what we have with I2, and what going against it? I1. Yeah. So it'll be I2, one that going with minus the one that going against is equal to 3 VA. Yep. And now we do I1 and I2. So now we have to do I3. Ah, would you look at that? What do I see there? It's a current source that not being shared. Yeah. Same people raising a hand. What's going on?
Um, so I know you said to ignore 2 to 6 and pretend it wasn't there.
For the super loop, yeah.
Yeah, it's free super loop.
Yeah.
I should still, well, I shouldn't let I1 cross into I2. Because I was thinking how I1 was going down for a second.
I1. What do you mean by that? You have to be more specific. So that we are
Uh,
not across it out front. Right. So if it wasn't there, right?
I just draw on the screen for a little bit.
Yeah, go ahead.
So from my brain was just thinking, I1 would have go here. Because we ignoring that green part.
I1 will I go. Nah. I know how it does. Yeah. This part here, the only two currents that in going through this resistor here will be I3 and I2. I1 not going through there. Because I1
Alright,
going so, so, and well, technically it will have go through here, but so.
I
That is the
understand.
I1. I2 is so. I3 is there. So I1 not even going through here. And what we assume, remember each rectangle is where I1 is bounded by. I1 can't play like it going through I3 far right. You had to stay in the box. Same thing
Yeah.
with I2, same thing with I3. So you had to note what loop you're in. So when I went through here, I went up to here, I went through here. So that's R14. I can't say minus 200 I2. How I2 reach up there? That in the I1 loop. So it will be minus 200 I1. Go down to 4, 5. This R1 here, the only two current going through is I3 because I in the I3 box and I in the I1 box. So that is the only two currents I go and get from R1. So now I'm not going through here, so I have to go down here. And this resistor here, this resistor joining the I2 box and the I3 box. Yeah? So since we in the super loop, I1, I2 is part of it. So when resistor are going against it, negative, anything going out with positive. That is why we got this part here. So let's be careful with that one. And you're back
Yeah.
to it. Yeah, so, all right, so nice. So I go back to right now, I'll link equation. So, yay, so that there already. I think I read already. So we handled already. So we're back to I3. So I3 have a current source that's not being shared in between any loops, and is the only current source in the loop, right? So I3, so is the current source going with or against it? So going with it. So I3 would just equal to 3. And that is it. So you do I1 and I2 get absorbed into a nice easy super loop. So that is that there. You write the link equation first, and then you handle the dependent. You have the dependent source. So I do that dependent source quick. So we have VA. Because this is a dependent. Remember, anything diamond is a dependent source, right? So there you go. So 3 VA. VA, where's VA? VA is here. So that's like we did before. That is a voltage rise. Yeah, it's a voltage rise. So there you go. So we can write out. So VA going from here up to here, right? So it have two currents going through here. We have I2 and we have I1. So think about it. Think about it very logically, right? I3 going in the same direction as VA, but there's a voltage rise, meaning going from a low to a high. So I2, if I go through I2, if I go through here, I2 will go from a high to a low, because in the I2 loop, you have a voltage drop. Yeah, but in the I3, you're going up here. So if we in the I2 loop, that's alone, look at the I2. That's how we did before. It'll be minus 1000 I2, and it'll be plus 1000 I3, right? And that will equal to, well, 0 in this case, right? So if I want to write the link equation for VA, right, it would just be the sum of these two. So since I want a voltage rise, yes, okay, let's factorize the 1000 per minute. So you'll end up with I3 minus I2, right? So that'll be the answer right there. Yeah, that's what it is. Nothing too special. It's literally the same thing we did before, just like the voltage drop across. Yeah, so now with this here, let's watch it, right? We ain't done yet. Watch it. So now remember, if I need I2 loop, there's a voltage drop. Yeah? Look at it. So VA going against what I assume. Boom, clock. So if it going against what I assume, it would just be the opposite. Can you run back real quick? Alright, so I'll start over with the correct thing I do want. So watch it. If I need I2 loop, remember VA going from a low to a high, right? So I expect a positive answer. Keep that in mind, I expect a positive answer. So if I need I2 loop, if I go in through here, you expect any voltage drop across here to be negative. If I need I2 loop, it will be negative. And I3 will be the positive one going up here. I3 here, I1 here. Yeah, the voltage drop across here will be a combination of I1 and I3 multiplied by 1000. It will always be that. But that's how to note which one you're choosing. So if we need I2 loop, you will get a voltage drop. So it will be, look at it. It's going against what I assume. Watch it, going against. This will be a voltage drop. If I need I2 loop, it will be a voltage drop. So it won't get what I want. I could use I2 to get it. I would just have to modify by -1 to get it to go in the opposite, which is a voltage rise I want. So that is what I said. So if I want the VA, I could use the I2. It just will be a resultant of two of these. So watch, there will just be VA. If I use any I2, it will be minus 1000 I1, I2, sorry, and plus 1000 I3. Alright, but since that it going down here, I want it to go the opposite direction. So it just be VA, it just multiply everything by -1. So that'll be 1000 I2 minus 1000 I3. It would just be the opposite, which is why I just factorize the 100 to make it look nice. Yeah, that's it. And that makes sense, because if I multiply 100 by I2, you will get the voltage rise through it. Because there will be a voltage drop across I2, because I2 going through the resistor. So if I multiply by -1, I'll get to rise up. And that is it. That's how I know your polarities. As I wish you all. Hey, that's how I know your polarities. If I had used I3, you'll like get the same thing. But using I3 makes no sense. So yeah, let's use I2. Right? So that's easier to use I2. And that is it. That is it. Alright. Remember our voltage V is equal to IR, right? So in this case, I is a resultant of these two things. So that is why you have to be careful. Yeah, and that's it. Yeah, that's it. All right, so yeah. Anyway, so I continue. All right, so I'll try one more. I don't know what you want to try. All right, there's a long one. So so this is the last one I would do. So step one, I label my loops. Yes, label my loops. So the second thing I need to do is look for super loops. All right, so I have a super loop here. I have a current source being shared in between two loops. So that's gonna go through this one. We're gonna do it because it's the same thing we do. So if I join in this super loop, it'll be here, up here, ignoring this for now, here, here, and well back to here. So this whole thing here will be a super loop. Yeah. So you can draw the same thing and if I go through it, it will be 10 minus 4I1, skip that, it will be minus 5I2, because I need I2 loop. Down to here now, it will be minus 5I2 and plus 5I3, because I3 going against it. Down to here, going through here, 4, so it will be minus 4I1, and then it'll be plus 4I5, because I5 going in the opposite, so we assume. Remember, you're drawing I1 and I2, and then you're back to where you start. Right, and you link equation, I3, I2 going up, I1 coming down, so it will be the current that going with it minus the current that going against it will equal to 3Vx by dialing equation. Alright, so obviously this loop and this loop are counted for. So this loop here, you have to do the same thing, literally the same thing. Right, this loop is the same thing. For this loop, you don't need to do anything because you have a current source, that is the only current source in the loop. So I4 will just equal to 3. It's in the same direction. Right, Vx. So same thing we did before, Vx. I5. This one you will see it better, right? Look at it. I5 going so. I'm back up, right? You notice that the voltage drop that they assume going against what we have. Because normally for I5, if you go through the resistor, you're expecting a voltage drop. Yeah? So and look at it. In this case here, if you look at it in the correct polarity, you'll get the correct answer. So watch it. Look at battery. We've had a battery here, right? This here will have a high. Watch it, right? Watch it carefully. This will have a high. And when it go through the battery, so the resistor, you will get a lower voltage. Look at it. And we are going from a low to a high already. Look, you're already seen it already. So Vx, we know the current is I5 and it's 4. That's it. You don't have to do anything special. It's already there. Yeah, you're expecting some positive pair rising. Rising. Yes, don't overthink it. Yeah. If that say Vx was going this direction, think about it, you're expecting a voltage drop. So yes, it'll be minus 4 I5 because Vx going any direction that you assume for I5, anything going in the same direction as I5 will be negative. Yeah, but in this case, I wanted Vx opposite to that. So you're expecting a positive value. Yeah, so that was positive 4 multiplied by I5. So you have to be careful with your polarities. Yeah, let's look at, they'll always give you the arrow. Let's look at the loop you're in I5 loop. Anytime you go through a resistor, you're expecting a voltage drop. So if let's say something going opposite to what I say for I5, it would just be the negation of that. It would just be positive in this case. Yeah, that's all it is. Nothing special. All right. You see the others? Well, it's the same thing. I just want to look at it to show all this stuff. So Vx is literally the same thing. Yeah, I hear another question. What's going on?
What about I3 loop?
Huh?
What about the I3 loop?
Well, I'm not gonna,
Finish on
it's
it.
the same thing you would do. Nothing special with this one. So you're like, all right, I'll do it for the I3. I just said that it's the same thing. So it made no sense I'm doing it again, because it's the same thing I'm gonna do. But if I see the answer for it, if I write it out, I3 go in here, and I2 go in. Look how fast I write it out. So we have minus 5 I3 plus 5 I2 can go in the opposite, so we assume. Then we have 3, so we minus 3 I3. We are here now, so now we have to go through this as a voltage drop. So it's gonna be minus 6 Ix back to G, and then we have minus 3 I3, and that is equal to 0. Ix is a dependent source. Where Ix is? Ix is here. That is a current, right? So Ix, what current, what loop Ix in? The I2 loop. Is Ix is the direction that I assume for Ix in the same direction I2? Well, yes, it is. So therefore, Ix would just equal to I2. If Ix was going in the opposite, so what I assume that just be Ix will equal to minus I2. But since the set Ix is in the same direction, it would just be Ix equal to I2, same direction. And how will I handle that? Yeah, and that's every dependent source must have a link equation. Luckily, Ix was in the same direction as I2 that we assume, so Ix was equal to I2. If it was opposite, it does negate it, so that does be negative. Yeah, that's how I did with I3. I just said that I3 will be the same thing, so I just skip it to jump to the Vx part. So to show you that the voltage drop across something is negative. So if they swap it, it could just be positive because we're looking for voltage rise. That's all it is. All right.
For the I4 loop,
I4, yeah.
you just ignore the 7 ohms and just
I
make
don't
the
need to do
inverse rate.
I don't need to do anything because I have this going on here. I have a current source that's not being shared in between any loop. So I4 would just equal to 3. You don't need to do anything special. From the time you see a current source that is not being shared in a loop by itself, that loop would just be the current source in the correct polarity.
Just 3 amps.
Yep, that's the easiest thing I've ever seen in a circuit. Just make sure the polarity correct, yeah? Because I4 in the same direction as this, so I say keep it here. If it was going in the opposite, I4 that's equal to minus I3. So let's be careful.
Yeah.
Let's look out for it. That's fair to look out for. If I scroll back up, look at the pattern, look how it does look. Look at it here. Current source not being shared between any loop. So I3 would that's equal to 3, which I have here. If I go back up, I don't think the other side one. Yeah, look at here, same thing. You have a loop, you have a current source that not being shared. Seeing that? So therefore I2 would that's equal to I4, which is 40, which is what I had here. Yeah, that's how I look out for it. This one, same thing here. Look, current source not being shared between anything. So this, if I label this I4, I4 will just be minus 3Vx. Because I will assume clockwise, right? And since it's going against it, I4 will just equal to minus 3Vx. Yeah? And that is all about it. For this one here, let me do the Vx for this one to show this up. So if I assume I1 is here, right? And then I2 is here. So Vx, I1 going here, right? And I2 going so. Think about it. Look at this here. Watch it carefully, right? If I wanted to add everything going through here, Vx going in the same direction as I1 is looking, it's the same direction. So anything going in the same direction, it would be positive. So if I write in the Vx for this one, all right, and piece by piece for two loops, because it will be a sum, right? Because two loops going through it. So I1 the same direction. Notice it. So this will be a high here, and this will be a low. Think about it. I1 is a voltage going through it. If you're going through this in I1, but in the same direction, look at it. So if in the same direction, it will start at a high and it will go at a low. So if I write it, it will be minus 10 I1. That is okay. In the I2 loop now, watch what's going to happen now. In the I2 loop, if the voltage drop across, this will be negative now. So, but since the arrow going in the opposite to what we assume for I2, it will just end up being plus. And that will equal to Vx. Yeah, let me do it up here so I can see. So if I say Vx is here, and I call this loop I3, right? So I3 going through here. This in the same direction as I3. Yeah, so you're expecting going from a high to a low. Yeah, because voltage before resistor had to be higher than the voltage after. That's how it does work, right? You can end up with more voltage after you go through the resistor. It don't really work like that. When you eat food, the pot does get less food in it. It don't grow. All right. So the resistor go and eat food, so the pot go and get less food. So you're going from a high to a low. So you're expecting a voltage drop. You'd be expecting a voltage drop. So if Vx, you just say Vx, well, that's equal to minus 3i3. Because that makes sense because it's going from a high to a low. So in that direction, you're expecting a voltage drop due to I3. But if that said this now, that wanted Vx to go in the opposite direction, if wanted to go like this, now it will go from a high to a low. So in this case, I3 going so. So that means it's going from a low to a high. So that's be the opposite of what I had before. So Vx will that end up being 3 I3. Okay, going in the opposite, going from a low to a high. So if I'm going from a low to high, obviously expecting a positive answer. Positive answer. If I'm going from a high to a low, you're expecting a negative answer. So that's what I do. If I put it somewhere else, here now, same thing, Vx. Name this I6, and this one here I4. So I6 going here, and I4 going up. So watch it. Just look at each loop separately. So if we join it up, for the I6 loop, it's going against it. So therefore, this will go from a low to a high. So if I need I6 loop, see it? Going opposite to what I assume. So we expect it to go from a high to a low, right? Same thing that we did before. So since you're doing like that, high to low, expecting positive, negative, positive, negative. So expecting it to be negative. So Vx for the I6, so it could be minus 6 I6. So now let's deal with the I4 loop now. So for the I4 loop, it's going in the same direction. So you noticing that it's going in the same direction. So expect it to go from a high, so a low to a high. So it'll be positive for this one. So it'll be plus 6 I4. Yeah, just like what we did before. It's literally the same thing. Just know the polarities that stuff over there. Yeah, and that's it for Vx answer. Alright. And that's I mean I don't really need to do anymore. I think at the end of the tutorial. Alright. So for this one here, same thing with the guy. There's our current source. So that's Uni's current source in this loop. So if I name this loop I2, what that's equal to, since it's going opposite, that'll be minus 2 Vx. Yeah, and you have a super loop here. So you just need to treat this whole thing here as a loop. Combine the two loops together. So this was I1 and I3. You just combine those two together and then write your loop equation for it. And you treat this one as separate. How about this one as separate? Yeah, that's all it. That's literally all it. Yeah, and I'll show you how to deal with VX already when they give you the voltage across a resistor. Alright, so with that said, I stop it because I have nothing else to go through. I already showed you everything I need to know from nodal and loop. So I stop it now for questions. Any questions? Any questions? But at the end of the tutorial, I have nothing else for me to do. Anything I want to go through? Well, everybody good. Going once, going twice, going 3 times by
So,
squared. Yes, I
when
listen.
you have a super
Super loop,
They have a
right?
super loop, you write in
Right.
the normal equation, and then you had to write the link equation.
Yeah.
So,
Yes. Yeah.
okay.
So in this, I hope you see in this current source here, I'm talking to you. So you see in this current source here, right? So if I name this loop I2, right? And I name this 2I3, you notice that this current source being shared in between I3 and I2. So anytime you see in that, you have a super loop, right? So the steps you need to do, for the first step, you need to write a super loop equation, right? So we can say I super loop, which will just be I2 and I3 together, right? So for that, you just assume that's not there for now. So the loop will go here, through here, just combine the endpoints of the two loops, right? And come back down to there. I'll put the super loop there. So you know you'll just when I go to resistor, negative, anything going opposite is positive, and you know normal thing. If you go to the battery, you know the polarity, normal thing. Alright, come back around, pow. So if I do this one quick. So it's gonna be minus 30 I2. So we here now, and it's gonna be plus. If I name this one I4, it'll be plus 30 I4. Going down, we here now, we come back down real quick. So it's gonna be minus 5 I3 because I3 is gonna be in here. And plus 5 I, I didn't name this one, I5. And then back to here, and then back to 0. So that would be the super loop equation. Now we have already link equation for the current source now. So that's 2 steps. What current going with it? So I2 go in here. So I2 going down. I3 going opposite, right? So that's like we see. The current are going with the current source minus the current are going against it will equal to the current source. And that is it. That's how you would treat the super loop. So now you treat I2 and you treat I3. So now you're going to write the equation for I4. Luckily, you don't have to write the equation for whatever this loop is, because you already have a current source there that not being shared in between anything. So you could just say if this was I7 would just be minus 2Vx. So you're going opposite. So we assume. And then this one, you had to write the equation for I5, which is a normal resist, normal thing. Battery negative drop, and your equation is it. Yeah, and that's how you treat a super loop with the other stuff. Yeah, so all right, nice. I hope that helped.
The
Any
super
other
loops have three
uh,
super loops have 3 equations. I1, I2, or I2, I3, and the link equation.
well, it don't have 3 equations. It depends on what resistors you're going through. So I went through this resistor here and this resistor here. Look at the resistor specifically and just look at what currents going through the resistor. Don't look at the loop as a whole. Okay, you get confused with the currents. So this resistor here, it only have 2 currents going through it, I4 and I2. Seeing that. Going through this one here, we have I5 and we have I3. And we're back to it. So the super loop equation will have one big equation that is a combination of the 2 loops that you went through, and then you have a link equation for it. So we just have 2 equations. The equations can have any combination of currents. It all depends on what resistor you go through. Because obviously for this 5 ohm here, right? You're going through, you'll have a I5 term and you'll have a I3 term. When you go through this 30, you go have a I4 term and you have a I2 term. If I go through this 20 here, I will have a I2 term and I'll have a I4 term. Yeah? So it all depends on resistors you go through. That will incorporate the super loop. Yeah, that's it.